Grasshopper tutorial for beginners, I want to show you how you can define a point attractor on a facade and create a series of parametric openings. As you can see here, we can control the minimum and maximum by using a remap. We also are going to talk about changing the opening based on the height. So if I just put this to true and false, you can see that we can put it based on height or from right to left. And also by reversing the data, we can reverse that. Okay, to get started, I'm going to use a vector grid, and let's get started with a rectangular grid here. So I'm going to put that on the canvas. And let's go to full name so you can see the input. Obviously, we need a plane, so I'm going to use an XZ plane here for this example. So we have this facade in the XZ plane. And if you wanted to change the location, you can simply right-click and extract the origin. I can just move that around. Okay, the size X and size Y is obviously the length and width of the rectangle. So I'm going to give that to the size X. We can name this length and also change the second one to the width and bring that up. And we also need to define how many numbers we need in the X and Y direction. So I'm going to say from 3 to 12. And also another one for the Y. Okay. After defining them, we have the cells here. I'm going to put them into a curve container. And because by default, the vector grid components, hexagonal, radial, rectangular, whatever here we have, it's going to be into groups. As you can see here, we have 8 groups of 7. That is because of this. So I'm going to flatten this. We don't need them in groups. We just want them all in one container or one group. Okay. So these are going to be the base of the rectangle. And obviously, this is going to be the module we're going to use here to define the facade. After creating that, let's create also a point attractor. For the point attractor, I'm going to use this trick, use the surface and a bounding box. Because this bounding box is per object, as you can see here, we have 56 flat boxes. I'm going to right click and select a union box. So we have only one flat box. Now that you have the box, you can use the surface evaluate surface. And remember that you have to right click and reparameterize it. So it's between 0 and 1 in the U direction and 0, 1 to V direction, and use an MD slider, which is going to control the point attractor here. So as you can see here, we can move it around. I'm also going to use 2 number sliders to make it more controllable. So we have 2 point attractors, for example, and we want to use that. So I'm going to turn that box off. And this is going to create the point attractors. Let's give that to the point, and that is going to be used in our project. The next thing we have to do is to find the center of these rectangles. So I'm going to use the curve polygon center. You can use surface area also, but this one is faster. So I'm going to use the center of area to have the centers, and we are good to go. Another thing we want to do here is to find the distance between these 2 groups. So if I go to the vector and use a point, the pull point component is really great for this. What you have to do, and as you can see, the default is closest. Okay, we want to, for example, these points on the grid are going to be drawn towards these attractors. So I'm going to say red. This is one of the attractors and this one is another. We have to say that, okay, this point belongs to this attractor. And obviously this point is going to be pulled towards this attractor. The point is going to be the center. And the geometry you want to pull towards, obviously you can give anything, even curve attractor, are going to be these points. And it's going to give you the distance and also closest point. If you want to visualize that, you can simply give a curve and a line with 2 points. One is on the grid centers and another one the closest point. And now you can see that these point attractors are going to attract those grid centers which are closest to them. Okay. So that is going to be for visualization, but what we need here is the distance. Give that to a number. That is going to be the distance here. If you want to show them, you can use display and tag on the center's location. The text is going to be this one. And if I bake it, you can see the distance on each of these cells. So this is going to be the amount for each of these rectangles we're going to use. Obviously, it's going to be used for how much we're going to offset that later and give it some thickness. So these numbers are going to be really helpful. Okay, after getting those distance, which is the main component we need here, let's go and do some simple stuff. And what I want to do here is to, for example, offset them a little bit inwards. So let's go and say